we are just doing it just to bring those one who have missed the other lesson back on board. Okay?
Yes.
Just write more examples. Question number 1. What is it saying, members? It is saying a box contains, and just to help those who did not attend the other lesson at that time, I said, when do we draw a probability tree diagram? When do we draw a probability tree diagram? We draw a probability tree diagram if the experiment or if the number of trials is more than one. Is more than what? Is more than one. That's when we use probability tree diagram. And when we use probability tree diagram, we use it to generate, the sample, is to generate the what? The sample what? The sample space, is to generate the sample space. This one, we use it if the number of trials or if the number of experiments is more than one. Like for this case, they're saying a box contains 4 red and 6 blue pens. A pen is picked at random from the box and not replaced. And not what? Replaced. So which type of selection is this? If you remember, we said we have two types of selections. Types of selection. Who can remind us? What are the type of selections that we have? We have with what? With replacement. This one where the number of items remain the what? Remain the what?
The same.
Remain the same. Then we have without
replacement.
Without replacement, where the number of items keep on what? Keep on reducing. Keep on what? Reducing, depending on the number of what? Picking, or depending on the number of selections or the number of trials for that particular experiment. So, like I've said, if the experiment was done only once, so there's no need for drawing a probability tree diagram. But if the experiment is done more than once, then it calls for probability tree diagram. And probability diagram means each branch, if you add the probability of each branch, because we say probability, it must be 0 less than or equals to, probability of any event must be less than or equals to what? 1. That's what we discussed. So when you add each branch, and if you add the total probability of that given sample, it must give you 1. It must not give you 1. If it's not giving you 1, then just know you have made mistake somewhere. So what you do, you collect the information. Like here, when you look at this information, what have they given us? We have red. So we can say let R represent red what? Red pens. And B represent, you have to let, and B represent blue what? Blue pens. So how many red pens do we have in that box? There are what? There are 4. Then blue, there are how many? Blue, there are 6. So which means total we have how many members? Total we have 4 plus what? 6, which is what? Which is 10.
10.
Which is 10. But if it was not done, if the selection was not done more than once, so then there was no need for what? There's no need for drawing a probability diagram. But this experiment was done 2 times, was done twice. So for you to help you to generate the sample space, the best method you can use, or what can help you to get the most accurate answer and correct answer, is using a probability tree diagram. So let's go ahead and, so it was what? Was it without replacement or with replacement? Because I'm saying a pen is picked at random from the box and not replaced. What does that one mean, members? This one, is it without what? Without replacement. And it was picked how many times? This experiment was done how many times? It was done how many times, members?
Twice.
Was done twice. Good. So probability tree diagram. Probability tree diagram. Probability tree diagram. probability tree diagram. So can you start drawing it? Can we start drawing probability tree diagram? So we have the box is there. Be smart, we have red and then blue. Red and blue. So this was the first picking. Be smart in drawing your probability tree diagram. This is red, this is blue. So that is our first picking. We separated by that line there to show that this is the first one. This is the first one. So what's the probability of picking red pens in the first one? And there were 4 red pens in that bag, in that box. So it's going to be 4 over what? The total. The number of events divided by the sample space. So our sample space is 10. Our event is 4. So 6 over 10. The second one, the second picking. Members, are you with me?
Yes.
All right. Red, blue, red, blue. Now we said we assume in the first branch here, we pick the first item, which is red. So if you assume that we have picked red, which means the number of red pens will reduce to what? To 3, not so? Which means also the number of items, because you are picking and you are not replacing, which means the number of what? The total number of pens in the box will reduce to what? Will reduce to 9. Because you are picking and you are not replacing it back, and you have picked what? A red pen. And you did not pick blue, which means the number of blue pens will still remain 6 out of 9. Now, when you come to the second branch, you also assume you have picked a blue. You assume you have, because there you have assumed you have picked red. Now here you are assuming you have picked blue. So if you have picked blue, which means the number of blue pens will reduce to 5 out of 9. You did not pick red, which means the number of red pens will still remain what? Will remain what? Will remain 4. So which means this will not be 4 over what? 4 over 9.
9.
Like that. Members, are we together on that?
Yes.
Yes.
Teacher, question.
Yes, please.
Why didn't we say 4 out of 10 on the second picking?
Because you are picking and you are not replacing it back. This one is without replacement. And we said without replacement, the number of items keep on what? Decreasing. Because you are picking and you are not putting it back. Okay? Which means the number of items will keep on reducing. Okay?
Okay.
Yes.
Teacher,
yes.
a third picking. You mean you are going to write like 2 out of 8 again? You're going to subtract from the 3 out of 8.
Good. If this experiment was done for 3 times, which means the third one here, it will be 2 out of 8. I think that. Okay, let's first do this, then we do for the third picking. This was the first one. We shall do also for the third one, okay? Are we together?
Yes.
Okay. This one was, there were 2 picking. This one, 2 picking. 2 picking. 2 picking. So this is our second. This is our second. So now this will be probability of picking red and what? And red. This one is probability of picking red and what? Blue. What do? You follow the branch. You follow the branch. Here, red, blue. You come to this one, blue. This is blue and what? And red. This one is blue and blue. Blue and blue. So you will multiply the probability along the branch. You multiply the probability along the branch. So we shall have 4 out of 10 times 3 out of 9. What do you get? We shall get 12 out of what? 12 out of? 12 out of what? 90. What about this one? This one will give us 24 out of what? Out of 90.
9.
What about this one? This one will also give us 24 out of 90. What about this one? This one will give us 30 out of what? 30 out of 90. Before even you go and answer the question, this is the proof checking you must do every time you're handling any question on probability tree diagram. You first confirm when you add these probabilities. When you add this probability, it must give you 1. It must give you 1. Can we confirm that? Can we confirm that? That is the litmus test of your question. If you cannot prove that, then your question is it, which means you have made mistake somewhere. When you add all this probability, must give you as what? Must give us 1. So they have the same denominator. Let's add the denominator. We have 12 plus 24 plus 24 plus 30. What do you get? We get 90. 90 out of 90 is what? Is 1. So which means we are on the right track. Which means we are on the right track. So can we answer the question now? Can we answer the question? Members, can we answer the question now?
Yes.
What is the question saying?
The first pen was red.
Okay, let me first adjust my camera. All right. What's the first question, members? The first question is what? The first question they want us to find?
The probability that the first pen was red.
The first picking, the first pen was red. So which means you come in the first picking here. I think the first one here, because they want the probability. Probability. The first pen was red. The first pen was red. What would be the probability the first pen was red? The first one is red. What is the probability? The first pen was red. What is it? Is 4 out of? Members, is 4 out of what? Is 4 out of what? The first picking here. So what is the answer? The probability is 4 out of 10. So it's 4 out of what? 10. If you reduce that, what do you get? By 2, you get 2. By 2, you get 5. So which means it's 2 out of? 2 out of 5. What about B? In B, what do they want?
Both pens are red.
Both are red. I mean, both were red. Both were red. So what were, which mean both were red? I think that red and red. What did we get here? Is what? 12 out of?
90.
Is 12 out of 90. So you come and put here 12 out of 90. If you reduce that, what do you get? If you reduce that, what do you get? 12 divided by 90, what do you get? Is 2 out of? Is 2 out of what?
15.
2 out of 15. C? In C, what do they want? Probability of? Different what? Different colors. So different colors. So which mean if they want different colors, which mean can be what? Can be red or blue. So it's the same as probability of red and blue plus blue and what? And red. That's the probability of for different colors. Here, this one here. This one, they will give us different colors. Different colors. So which means we shall have 24 out of 90 plus 24 out of what? 90. If you follow from, so they have the same denominator, so I have 48 out of 90. 48 out of 90 is what? What is 48 out of 90? Is the same as, if you simplify, is
4 to
8,
15.
is 8 out of, is 8 out of, 8 out of what? 15. Are we together? We can add the question here. Let's add another question there. What if they were asking probability, the same color, same color? Same color here would be what? Members, what would be the same color? It is going to be probability of red and what? Red, then blue, blue and what? Blue and blue. What was the probability of getting red and red? Was it 12 out of 90 plus what was getting red and red? Red and red, I mean blue and blue, we got 30 out of, is 30 out of what? 90. 30 out of 90. So which will give us now, which will give us, this will give us 42 out of 90. But what is 42 out of 90? 42 divided by 90 would give us what? 7 out of? 7 out of what? 15. Members? Members?
Yes.
Yes, teacher.
Have you seen it now?
Yes.
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 You have understood, eh?
Yes.
Now we are going to do this same question, this very number, this very what? Eh? This time, this one was 2 picking. Now let's do it 2 picking, 3 picking. This time there were 3 times. They were picked how many times? 3 times. Let's see how it will come out, because I want people to understand.
Teacher.
Yes?
I have a question.
Yes, please.
Probability shown by number of events divided by sample space.
Yes.
But the sample space, which is supposed to be down, is more than the number of pens we have.
It's more than what? Which one? Which one?
7 out of 15, yet we only have 4 pens. Yet we only have 10 pens.
that's what. Did you attend the other lesson, Letitia?
Teacher, I didn't attend it.
Hey, Letitia, we are getting it from here. We are getting everything from here. This one, we are adding the branch, is we are multiplying the probability of each branch. Okay? But what are the chances that you will get? This one is combined. This one is combined. This is the chances of picking the same colors from the what? From the box. Does not mean that this should be the same as the number of items in that box, but that's the chances of getting it. Okay? Are you together? Members, are we together? Yes. So now let me add another question here. They may ask you, what is the percentage? What is the what? What is the what? The percentage of getting or picking pens of the same what? Of the same what? Of the same color. What will you do? So you first get the probability, but what is the first thing we have to do? What's the probability of picking the same? Probability of the same what? Probability of the same color. We got what? We got what? We got 7 out of what?
15.
Out of 15. Now, what about percentage now? What about percentage? What would be the percentage? Because they were asking percentage, which means you're going to say 7 out of what? 7 out of 15 times what? Times 100 per? I think that. What do you get? What do you get? 7 divided by 15 times 100. So what's the chance? The chance is what? 40? 46 point what? 0.7 what? Percent. Letitia, have you seen that?
Yes.
Members, Members,
Yes.
are we
Yes,
moving?
teacher.
Are we together?
Yes.
Are we together
Teacher.
now? Are we together now?
Yes.
All right. Now I'm going to do the same question, but this time still with what? Without what? Without replacement, but how many pickings? 3 what?
3 pickings.
3 pickings. Okay.
Yes.
Let's draw our probability tree diagram. The same question. We are not changing anything. Probability tree what? Diagram. You give enough space because this time we are moving 3 times, so you can start our work from here. Start our work from here. Red, blue. Red what? Blue. Red, blue. Naro Kenge.
Yes, teacher.
This is our what? This is our first picking. That is our first what? Picking.
Picking.
What will be the probability of picking red? Will be 4 out of?
4/10.
Then this one will be 6 out of?
6/10.
That is the first one, right?
Yes.
We go to the second one. We go to the second picking. Red, blue. Red, blue. I said, what do we do? We assume, not so? Members, what do we do?
We assume.
This is our second picking. So in the second picking, in the first branch, I see the first branch here.
Yes.
We assume that we have picked what? We assume that we have picked what? Red. Not so? Which means red will reduce to 3 out of what?
No.
3 out of 9. Then this one will remain 6 out of 9.
9.
Here we come to, here we assume that we have picked what? Red. I mean, we assume that we have picked blue, which means blue will reduce to 5 out of 9.
9.
I did not pick red, which means red will still remain what? Will still remain 4 out of
9.
I think that.
Yes.
Do we stop
Yes.
there? Do we stop there?
No.
What do we do? We continue,
No.
not? We continue, right? Because there were how many pickings? There were 3. There were 3 pickings.
Pickings.
Continue on each of them. Each of what? Each of them. And be smart when drawing this. Be smart, please. The more organized you are, the more accurate the more easy it is for you to follow your work. So this is our members.
Yes, teacher.
This is our third what? That's our third picking, not so.
Yes.
Red, blue, red, blue. We shall assume the same. In the first branch here, we assume that we have picked what?
Red.
Red. If you have picked red, what will happen to this? This one will come 2 out of
2 out of 8.
2 out of 8. I did not pick what? Blue, which means red will be what? Red will be what? I mean, blue will be 6 out of
9
Out of 8.
6 out of 8. Red, blue. So here I will also assume, here we assume we are pick red. Now here we'll assume that I'll pick blue. I think that.
Yes.
If you are pick blue, which means blue will be what? 5 out of?
5 out of
8.
Because here was 6. Now which means this time we reduce to 5. I did not pick red, which means red will remain 3 out of? I think that, members.
3 out of 8.
I think that.
Yes.
Red, blue. Now this time I'm going to make repetition. Now here we'll assume that here we assume we are pick blue. Now here I'm again going back to red. I think that.
Yes.
If you are pick red, which means red will be what? Red will be 3 out of
2 out
7.
3 will be 3, not so.
3 out of 7.
3 out of 7, 3 out of
3 out of
8.
8.
I think that. Blue was 5, which means blue will reduce to what? Blue will reduce to 4 out of what? I mean, blue will remain the same, 5 out of 8, not so.
Yes.
Then red, blue. Then here we assume that we have picked what? Blue. Which means blue will be what? 4 out of
8.
Then
Out
red
of
here,
8.
red here was 4, which means red will remain 4 out of.
8.
I think that in each branch, when you add the probability, must give you 1. 4 plus 4, that is 8. 8 over 8 is 1. 5 plus 3 is what? 8. 5 plus 3 is what? 8. 2 plus 6 is what? Is 8. Not so.
Yes.
Members, have you seen that?
Yes, please.
Yes. So let's multiply each branch. So now here is what? Here is the probability of red, red. Not so?
Red.
Then here is what?
Yes.
Here is the red,
Red, blue.
blue. Then here is what? What about here? Red,
Red,
blue,
blue,
red,
red. Then here is what?
blue,
Red. Eh?
Red,
Blue,
red,
blue,
blue,
blue. Not so?
yes.
Then here is it? Blue,
Blue,
red.
red.
Then here is it? Blue,
Blue,
red,
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 blue.
blue,
Then here is it? Blue,
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 red.
red,
red,
Here is it? Blue,
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 blue.
blue.
I think that. To simplify our work, I said, what do? You first get the probability in each branch, not so?
yes.
Can we multiply them and give me the answer, please? Here you will have 4 over 10 times 3 out of 9 times 2 out of 8. What do you get?
4 over 10.5.
This time, this is what? You will have 12, not so? You will have 12. 12 times 2 is what? 20. 24 over what? This is 90. 90 times 8 is what? Is 720, not so?
Yes.
Yes.
You here you'll have 4. 4 out of 4 times 3, that is 12. 12 times what? Times 6. You get 70? 72
72.
out of 720. 4 times 6, that is 24. 24 times 3. 24 times 3. You also get 70? 72 out of 720. Members, are we following?
Yes.
Yes.
4 times 6, that is 20? 24.
24.
24 times 5? 24 times 5?
120.
120 out of 720. Okay?
Yes.
We come to this. 6. 6 times 4, that is 24. 24 times 3. 24 times 3?
72.
72 out of 720. 4 times this, that is 24, right? 24 times 5?
120.
120 out of 720.
20.
5 times 6, I mean 5 times 6, 5 times 6, 30.
30.
30 times 4,
120.
120 out of 720. Then 5 times 6, that is 30. 30 times 4, 100 and what?
120.
Out of 720. Can we prove our answer, members? Can we prove? We said when we add all of this probability, must give us what? When we add all of this, must give us? Must give us 1. So let's add all of them. We have 24 plus 72 plus 72 plus 120 plus 72 plus 120 plus 120 plus 120. What do you get there? 700 and what?
20.
And 720 divided by. I think that.
Yes.
So which means we are correct. Which means we are correct. We shall answer the same question now. This time, let's say the question is. What is the probability of getting same color? What's the probability of getting same what? Same color. Same color here, which mean what? Red, red, and red plus what? Blue, blue, and what? And blue. Members, have you seen that?
Yes.
What was the probability of getting red, red, red? Was 24 out of? Was 24 out of 72? I mean 720. Then this was 120. So you come here and say 24 out of 720 plus 120 divided by 700 and what? 20. So if you simplify that, what do you get? You will get 140. 140 what? 44 out of 720. When you simplify, what do you get? 144 divided by 720. You find this is going to give us what? 1 out of what?
A fifth.
5. B. Probability of getting different colors. Different colors. What will be different colors now? Different color we shall add which and which? Different colors. Members, which one are we going to add? We have less than a minute. We have less than a minute, please. So which means
Red, blue, red.
we shall add this one, not so. We shall add this one, not so. This one.